So, as a continuation of previous lecture about Fourier series, let me continue with what's called Fourier of range series. Okay. So today we are going to see about Fourier of range series. Okay. So this is also a very simple concept. As I have already told, Fourier series is defined in the period of 2t, right? So it can be either from minus pi to pi or 0 to 2 pi. Okay. So this is Fourier full range series. Okay. Fourier full range series. Okay. So what's the Fourier transform of for a function f of x defined in the limit in the period from 0 to pi, okay, or minus pi by 2 to plus pi by 2, okay. So if we notice, the period here is just t, okay. Instead of 2t we have t, or in other way it's just a period of pi, okay. So if we have something in this period, then the usual question is either they ask to find the Fourier transform of f of x, Fourier sine series transform or cosine series transform, okay. So the Fourier cosine series transform is given by, it's nothing but the same formula but slight differences, okay. Instead of 1 by pi we have 2 by pi here, and the limit is from 0 to pi. In the previous for full range series we have 0 to 2 pi, but here we have 0 to pi and f of x cos nx dx, okay. So there is no change. So this is Fourier cosine series, okay. In this case we have bn equals to 0, okay. Suppose if they ask you to find the Fourier transform of f of x given in this limit or in this limit, and if they ask to find the Fourier sine transform, then the Fourier sine transform is nothing but 2 by pi integral 0 to pi f of x sin nx dx, okay. Here an equals to 0, okay. So this is the formula. In both the case a naught, right, a naught equal to 2 by pi integral 0 to pi f of x dx, okay. If they ask to find the Fourier transforms and if they put the limit like this, that is ranging from 0 to pi or minus pi by 2 pi, and if the question is only Fourier transform, then you have to find both a naught as well as an and bn, okay. If they particularly ask Fourier sine transform, then you have to do this one, okay. If they ask Fourier cosine transform, you got to do this one, okay. Okay, let me do a simple example. So it's example, okay. Find the Fourier sine series for the function f of x equals to e power ax for the range 0 less than x less than pi. Okay, so here clearly it is an off range series. So also they have asked to find the sine series, right? Okay, so to find the sine series is nothing but our bn. Okay, so bn is 2 by pi integral 0 to pi f of x sin nx dx, right? Okay, therefore we have 2 by pi integral 0 to pi. Instead of f of x we have to put e power ax, right, sin nx dx. Okay, so this is a standard integral and the value of the integral is, I keep this 2 by pi here. Okay, 2 by pi, and the value of the integral, this is a standard integral, you have to memorize this one. Okay, you have to memorize for e power ax sin nx as well as for cos nx. Okay, so the standard integral is e power ax divided by a square plus n square a sin nx minus n cos nx. Okay, and we have our limit 0 to pi. Okay, upon substituting the above limit, upper limit, we have 2 by pi e power a pi divided by a square plus n square a sin n pi minus n cos n pi. Okay, and if we substitute the lower limit, we have e power 0, so 1 divided by a square plus n square, and this sign of 0 is 0, so we won't have this term. So we have minus, it is multiplication. Okay, it is in multiplication, so minus n into cos of 0 is 1. Okay, cos of 0 is 1, so we have 2 by pi e power a pi divided by a square plus n square here sin n pi is, so substituting this pi here, so this term becomes 0, so we have e power a pi divided by a square plus n square, and this one is minus n times cos n pi is minus 1 whole power n, right? And here we have minus cos 0 is 1, so minus of minus plus n divided by, so this is in multiplication, we have a square plus n square, right? Okay, so if we see we have this n a square plus n square and n a square plus n square, so we can take this out common, therefore we have 2 by pi n divided by a square plus n square so So we have e power a pi, right? And we have minus of minus 1 whole power n. Here we have minus and this minus of 1, okay, plus this is 1, right? Okay. So we can rewrite this as 2n by pi of a square plus n square, okay. I am taking this out and multiplying with this of, I am bringing this one in the front side, so we have 1 minus e power a pi into minus 1 whole power n. So this is our bn, right? Okay, let's try to find b1 and b2. Okay, so b1 is, if we want to find b1, we have to substitute n equal to 1, okay. b1 equal to 2 by pi a square plus n square, and this becomes n power 1, therefore it's minus, so minus of minus is plus, therefore we have 1 plus e power a pi, okay. This is our b1, okay. Similarly we can find b2. b2 equals to, so we have 2 into, instead of n we have to put 2 divided by pi of a square plus, okay, sorry, here I have to put, instead of n I have to put 1, okay. Here I have to put 2 square, which is 4, okay, because we have n here and we are finding b2, so instead of n we have to put 2, okay, therefore we have 2 square. And here, since this is minus 1 of 1 square, so this is a positive 1, therefore we have a negative, therefore we have 1 minus e power a pi, right? Therefore our Fourier sine series for this half range is, here we have f of x, we know that f of x equals to b1, so we have summation n equals to 1 to p. So this is an off range sine series, so we have bn sine nx, right? So this is our off range series. So instead of f of x we add e power ax, okay, and this we can write as b1, okay. So for, and just substituting just b1 and b2, okay, in this series, okay. Therefore we have, we can take this 2 pi outside, therefore we have 2 by pi as a common factor. Then what else we have is 1 plus e power ax divided by a square plus 1 square sine x, because this sign is coming here, plus, since we take 2 by pi outside, we are left with 2 by a square plus 2 square, instead of 4 I am writing as 2 square sine 2x plus etc. Okay, so this is the final answer. So this is a simple problem, provided you must remember this standard integrals and these off range and full range techniques. Okay, so next we can see change of intervals. Okay, next thing is change of intervals. Okay, so this is when they give a function, when they will ask to find the Fourier series, okay, of a function f of x, and they give the range as from minus c less than equal to x less than equal to c. Okay, something like this. Okay, here you can have anything. You can have a 2 minus 2 to minus 2 to 2 positive 2, or from minus t to positive t, something like that. Okay, they give some values. Okay, example, they can ask you to find the Fourier series of function f of x equals to x, okay, in the range minus 2 less than x less than 2. Okay, something they asked to find the Fourier series in this range. Okay, if they asked in the previous section, we have seen that we can know how to find the Fourier series. They provide the full range series, that is minus pi less than x less than pi. It's a full range series, or it can be from 0 to 2 pi. Okay, this is full range series. We know how to find the Fourier series for this one. Similarly, we also know how to find the off range series. Okay, that is minus pi by 2 to pi by 2, or from 0 to pi. Okay, so this one is off range series. So this is off range, and this is full range. Okay, now what we are going to see is, we are going to see how to find the Fourier transform for an arbitrary interval. Okay, so if they provide an arbitrary interval, then the Fourier coefficients a0 equals to just a simple change. It's 1 by c integral 0 to 2c f of x dx. Okay, and our an equal to 1 by c integral 0 to 2c f of x cos n by x divided by c dx. Okay, and our bn equal to 1 by c integral 0 to 2c f of x sin n by x divided by c dx. So if you notice, the change is here. Okay, we have an extra term pi by c. Okay, pi by c here, and also these are the changes. Okay, so if they provide an arbitrary interval like from minus 2 to 2 to 2, or minus 3 to 3, anything, then this is the c. Okay, the limit, this is the minus c and this is the plus c. Okay, then you have to find the Fourier series using this formula. Okay, so this is a full range series, and the period is 2t. Okay, so this is for full range series. So this is full range series. Okay, similarly we can also have off range series. Okay, as we seen earlier. Okay, for the off range series, so this is the off range series. Okay, there is only slight difference. Okay, in the formula, our a0 equal to, instead of 1 by c, we have 2 by c. Okay, and the integral runs from 0 to c. Instead of 2c, it runs from 0 to c. Okay, and this and everything else are same. Okay, dx, and our an equals to 2 by c integral 0 to c f of x cos n pi x divided by c dx. Okay, and bn equal to 2 by c integral 0 to c f of x sin n pi x divided by c dx. Okay, so this is the off range series, and the above one is full range series. In the off range series, you will have it runs from say -1 to not -1, it runs from minus off to off. Okay, it can runs from minus off to positive off, or from 0 to 1. Okay, so this is the off range, because the period is here only one units. Okay, the difference is 1. Here also it's minus off to 0, so we have an off, and 0 to off, so we have another off. So the total period is only 1 unit. Okay, it's 1t. Or else it can be from 0 to x less than L. Okay, L can be any value, but if it is like this, then it is off range series. Okay, if it is a full range series, what we have is 2L. Okay, so it's a full range series. So since this is an off range series, we have only L. Okay, in this case, this is the C. Okay, you have to substitute in L instead of C here. Okay, sorry, instead of C, you have to substitute L and find out all these integrals. Okay, let me work out one example so you can understand this one. Okay, let me work out an example for full range series. Okay, so this is an example for full range series. Okay, find the Fourier transform. Okay, so this is an example. I asked to find the Fourier series. Okay, Fourier series for f of x equals to mod x. Okay, so this is an important thing. Mod x has a different property. So, and it is defined in the limit -2 less than x, okay, less than 2. Okay, so it is defined in this limit. Okay, so let's try it. So this is a full range series, and our C is this one. Okay, we have C, so this is our C. Okay, so we have full range series, and the formula is A0 equal to 1 by C integral 0 to 2C, since this is a full range series, f of x dx. Okay, and An equal to 1 by C integral 0 to 2C f of x cos n pi x divided by c dx, right? And Bn equal to 1 by, sorry, this is 1 by c. Okay, so 1 by c integral 0 to 2c f of x sine, it should be sine n pi x divided by c dx. Okay, so since this is a mod x, mod means it is positive when for all values of x. Therefore, we have to split this f of x. Okay, so this f of x equals to minus x in the range -2 less than x less than 0, and this f of x is plus x in the range from 0 less than x less than 2. Okay, so let me write down A0 of x. A0 of x is 1 by c. Instead of c, we have 2. Okay, this is our c. Okay, this is our see integral, and we split the limit. So first integral runs from -2 to 0, okay, from -2 to 0, okay, and in that case f of x is minus x dx, right, plus, so this 1 by c, so instead of c let me put 2 here, okay, and plus integral from 0 to 2. In this limit our f of x is x dx, okay. So this is our a naught. You just evaluate this integral and find the a naught, okay. Similarly for a n we have I am just taking this 1 by 2 outside, okay. So 1 by 2, it's a common thing. So we have integral from -2 to 0. Instead of f of x I have to put minus x, right, cos n pi x divided by c, right. So our c is 2. It's not -2, it's just 2 dx, right, plus integral from 0 to 2. Here f of x is x, cos n pi x divided by 2 dx, okay. You just evaluate this integral and find an, and for bn we have 1 by 2 because it's c, so c is 2 in our case, and integral -2 to 0 minus x sin n pi x divided by 2 dx, okay, plus integral 0 to 2 x sin n pi x divided by 2 dx, okay. So this is the c, okay, and this is also c, and the integral runs from 0 to 2c, okay. So find a naught, an, bn, and substitute this in the form f of x equals to, instead of f of x you have to substitute the mod x, okay, mod x, and in the full series is a naught by 2 plus summation n equal to 1 to p an cos nx plus summation n equal to 1 to p bn sin nx, okay. So this is the final answer. So next let me work out an example for off range series. So this is example for off range series, okay. So find the Fourier transform. Question is find the Fourier series, find the Fourier series for f of x equals to minus x by L plus 1, okay, and in the range 0 less than x less than equal to L, okay, L, okay. See, the length of this interval is 1 units, okay, it's L, okay. So this is obviously an off range series, okay. If it is from 0 to 2L or minus L to L, then it is a full range series. So this is an off range series. So for off range series we have a naught equal to 2 by c. Here the c is this L, okay, this constant 2 by c integral 0 to c f of x dx, and an equal to 2 by c integral 0 to c f of x cos n pi x divided by c dx, right, and bn equal to 2 by c integral 0 to c f of x sin n pi x divided by c dx, okay. The change is only here, we have to and in the range is not from 0 to 2c, instead of 2c we have c. Okay, so if we substitute this, we have a naught equal to 2 by c. Instead of c we have to put L, and integral 0 to L, and our f of x is minus x by L plus 1 into dx, right? Similarly, for our a naught, an, we have 2 by L integral 0 to L minus x by L plus 1 into cos n pi x by c. Instead of c we have to put L dx. Okay, so this is our an. Okay, similarly bn equal to 2 by L integral 0 to L minus x by L plus, this is L, okay, plus 1 sin n pi x by L dx. Okay, so find all this a naught, an, bn and substitute in the Fourier series f of x equal to a naught by 2 plus summation n equal to 1 to p an cos nx plus summation n equal to 1 to p bn sin nx. Okay, and this is the final Fourier off-range transform, Fourier off-range series. Okay, so throughout this Fourier series exercise you will encounter these integrals. Okay, again and again, so you try to memorize these integrals. Okay, so if you provide a limit, then you can remove this c, you no need to find this c. Okay, so since this is an indefinite integral, I have added the constant term. So if you provide a limit, then you can remove this c. Okay, so that's it. In the next video I'll try to give work out Fourier transform. Okay, so this, up to this we have worked out Fourier series. Okay, so we have worked out Fourier series, full range series, off range series for definite period, and we also worked out the full range and off range series for an arbitrary intervals. Okay, so with this the Fourier series exercise is over. In the next video let me explain the Fourier transform. Okay, that's too a simple one. You try to work out as many examples as possible, so you get familiar with this exercise. Okay.